know that erythrocytes only last for about 120, 128 days. They can be broken down in the liver or the spleen, and that's a natural process. When an erythrocyte goes to the spleen and it's time to break down, first thing that happens is it does burst open. And if it's in the liver or spleen, it meets up with a macrophage, which is a cell that's meant to eat and break down more parts of that erythrocyte. So the macrophage eats the erythrocyte, traps it into a vesicle, and pours digestive enzymes into the vesicle, destroying the erythrocyte. In the spleen, worn out erythrocytes, they do hemolysis first, which can be done with some proteins in the immune system called MAC or membrane attack complex. Either way, if the erythrocyte meets up with those proteins or whether it just does hemolysis by itself, the contents of that erythrocyte, which are basically just hemoglobin, all of the contents of that erythrocyte is released. Upon first opening up an erythrocyte, hemoglobin and amino acids just start pouring out, right? And these amino acids here, they are immediately packaged into a vesicle for recycling. They're transported to the bone marrow and they can be used to make more erythrocytes. If pure hemoglobin has been released, then this hemoglobin is broken down into its component parts of the hemopigment and the amino acid chains. Again, if it's the hemoglobin has to be broken up, its amino acid chains are packaged to go to the bone marrow and be reused. The hemopigment gets broken down into iron and bilirubin. The bilirubin leaves the liver by way of the bile duct and it enters into the small intestine where it's used to digest fats and is reabsorbed, or it doesn't digest fats and it gets excused as feces. Of course, as you expect, most bilirubin gets reabsorbed and recycled to use more erythrocytes, right? Any bilirubin that's not reabsorbed is excreted into the colon. We're not done yet. The iron gets picked up by transferrin, which is basically just a transport protein that's in your blood. It's a globular transporter and it's recycled over and over. It recycles the iron, bringing it to the bone marrow to make more erythrocytes. We can measure the amount of transferrin in your blood, and any that is not occupied by iron atoms means that you have a deficiency. You want all of your transferrin to be occupied, all of it. It should always be occupied, always. If some of it isn't occupied, that means that you are not taking in enough iron to occupy them. Your liver makes only the perfectly correct amount of transferrin for your blood. So none of it ever should be unoccupied. This molecule here is called ferritin, and ferritin is more about iron storage, and we can measure your ferritin levels as well. And if your ferritin levels are low, then yeah, you're not taking it in, or you're not storing as much iron as you should. If hemolysis doesn't happen in your liver or spleen, you can possibly get the breakdown products of red blood cells in your urine, which is called hemoglobinuria. I just like saying that, hemoglobinuria. Anyway, that's not terrible if you have the breakdown products in your urine, but there is something called hemolytic anemia. It's an autoimmune issue, and sometimes it's an autoimmune issue that's caused by other autoimmune issues, and it produces hemoglobinuria. If you have full red blood cells in your urine, yeah, that's bad. That's hematuria. You should never have full red blood cells in your urine. Your kidney is like a filter, and if you're getting full red blood cells, your filter's broken. the holes in your filter are too big.